Ladies and gentlemen, a very, very big welcome and thank you very much for joining me for lecture number 3, where I'm going to be talking about chapter 5 and chapter 6, estimating project times and costs and developing a project plan. These two aspects are very, very essential. Why are they essential? Why do you guys need to know about them? Well, because a lot of the work in Microsoft, in developing projects in general, is about knowing all of these plans and developing the plans and implementing the plans. Now, to be able to get the plans to be implemented, to manage and deliver the project within time, within cost, within specifications, you need to know what is the cost. We need to know what is the time. You need to know what is the plan. What are the due dates? You can't know that if you're not going to be creating all of these estimation and so on to get the goals to go and be delivered. So what I would want to say to you is we need to go and think about all of that into details to get the right outcome. So I will go and talk about them to help you, not simply learn, but also to do well in your assessment, which will rely on knowing these topics, to do well in your quiz that is coming up next week, which is worth, I believe, 5%, and to do well in your midterm exam that is actually worth, I believe, 20% of your mark. So all of these guys are very, very essential to be able to get the right outcome. You need to make sure you know them. You need to be focused every single second, here as well as in the tutorial, because what I'm covering here, you are going to be implementing directly in the tutorial. So please make sure that that we're going to go and actually get the focus that is required. The learning objectives is we're going to understand estimating project times and costs, which are the foundation of the project planning and control. We're going to talk about, describe the guidelines for estimating time, costs, and resources. We're going to describe the methods, uses, and advantages and disadvantages of top-down and bottom-up estimating methods. We're going to distinguish different kinds of costs associated with a project. We're going to suggest a scheme for developing and estimating database for future projects. We're going to understand the challenge of estimating mega projects and describe steps that lead to better informed decisions. We're going to understand the linkages between the work breakdown structure that you need to develop in details for your assignment and the project network. We're going to learn about the network diagram, which you will need to go and make sure you're going to demonstrate you know how to do in your midterm exam as well as in your final exam. We're going to need to calculate early, late, and slack activity times, which most likely would be a final exam question. We're going to identify and understand the importance of managing the critical path. What is the critical path? You need to know about it. And we are going to be distinguishing between free slack and total slack. Now, ladies and gentlemen, this is a small sketch, How long will your project take if I add 2 more people? Well, what I need you to know is adding more people doesn't mean that it's going to be better. Doesn't mean that it's going to be quicker. Adding more people is actually meaning it is going to start taking me much more time. Adding more people mean there's more complexity, there's more coordination, there's more drama, there's more negotiation that needs to go and be happening. So when you go and say, I am adding more people, that does not necessarily mean I am going to go and become more efficient. That is not how it actually works. So you need to work in an efficient manner. You need to plan well, have the resources well. And these are topics we're going to go and continue talking about now and in the future. We talk about an estimate. No one knows what is going to be happening in the future. So as project managers, we try to create estimates. We try to forecast the time it's going to take us to complete a specific outcome. We have an objective, we have a deliverable, we have a work package. We're going to say, we're going to estimate how long is it going to be taking me to be able to go and deliver that specific activity. And when we say we are going to be working based on that activity, because we know how long is it going to take and who's going to be employed to do it, we're going to know the estimated cost and we're going to be able to go and manage that according to that cost. So when I talk about estimating, it's really the process of forecasting or approximating the time and cost of completing a project deliverable. The task of balancing expectations of stakeholders and a need to control while the project is implemented. That's why we actually estimate, because you're going to have a stakeholder, you're going to have a CEO, you're going to have people who work with the team, you're going to have people externally, you're going to have customers, They're going to expect from you to know when you are going to be delivering a specific outcome for them, and also a lot of time at what cost. So when I talk about estimating, there are various types of estimations we go and have. There's what we call a top-down estimates, and we have a bottom-down estimates. And we are going to talk about these in a minute. But bottom line, top-down estimates are the ones that are high level, and bottom-up estimates is the one that consider the detail, every single, if you want, the work task that needs to be done in the project, and they try to estimate those work tasks accordingly. Now, why do we estimate, guys? Well, to make good decisions. Okay, when we know what time we need to finish, when we know the cost, that is, for delivering those outcomes. If we are, over time, if we are over budget, we can actually go and start making decisions. What do we need to go and do to try to go and really fix the problem? We plan because we want to go and schedule the work. We want to determine how long the project is going to take. How much is it going to cost me? Because that will tell me whether I delivered the project within time, within cost, within specifications. I plan because I need to know, is the project worth doing? If the project is going to go and finish in 2 years and I need it to be delivered in 1 year, well, it's not worth doing. If the project is going to cost me 2 million, but it's going to only generate a profit of 1 million, it is not worth doing. We plan because we're going to go and try to create a cash flow. So if I go and create a estimate of the costs across every single work package, and I know when it's going to start and when it's going to end, I know, okay, for this specific stage of the project, I'm going to need 50,000. For this stage, I'm going to need 100,000. For this stage, I'm going to need 200,000. And you start monitoring how much is it costing you versus how much you planned it was going to actually cost you through a plan. We go and estimate because we know how well are we progressing. Are we progressing on time, on budget, or not? We plan to develop a time phase budget and establish the project baseline. The project baseline is I save the whole project and say, okay, how much is my whole project going to actually cost me from an estimate perspective? We do that from the beginning, and we'll try to go and try to make that understanding. My friends, times for a thumbs up. Is everything clear so far? If yes, all what you do is just send me a thumbs up and I'll know you're good. Anish Adhikari, Japneet, and Milan Limbu. Guys listening? Okay, Milan Limbu, Anish Adhikari, are you guys live?
Yes, sir.
Okay, stay with me, please, okay?
Sure, sir.
Thank you very much, guys. All right, so I'll continue, guys. There are many, many factors that affect whether we are going to be creating a quality estimate. If you are planning for a very long time in the future, if you are actually having a long project duration, these are two things that are really related. That what you do with that is the longer you are going to be planning for, the more it is going to actually be potentially subject to having the wrong estimation. The people you are employing in your project will influence whether your estimates are correct. Some people are very good at estimating. Some people, however, are very poor and don't have the right knowledge. The project structure and organizational structure is another factor that will make an impact. We spoke a few weeks ago about the structure. We spoke about the, traditional functional structure. We spoke about the projectized structure. We spoke about the structure where we're using the functional department as well as the project department. So it's this kind of in-between approach of managing a project. Now, the structure is going to influence your estimates. If you are going and making people work on their functional departments and at the same time working on a project, then guess what? Your estimates are going to potentially be wrong. There's going to be a lot of things that might actually not be accurate because these guys are not very focused on your project. These guys might give you an estimate, but if something becomes available and for them to go and work on, and it is something related to their specific work function, your project will go and have a second priority. So you think about that perspective. You know, if I'm in a marketing department and at the same time I'm working on a project, well, if my main job is marketing and I know things are not running according to plan, or my manager of the marketing department come and say, I would like you to do some extra work, guess what? I'm going to drop the project work because that's not my main work. So your estimates will start becoming incorrect. Another factor that influences the quality of your estimates is the padding of estimates. A lot of time what people do, you tell them, okay, how long is that going to take? If it's going to take 10 days, they'll tell you 15. So they try to increase the time it's going to go and actually take to deliver something. Why do they do that? They do it because they're trying to go and gain more time. So they tell you, see, we've done it for you. We delivered it within the time. The culture. You know, for example, there might be a culture that don't care so much about project management. There's the culture that that doesn't actually focus on encouraging mistakes. For instance, if you are a culture and in that culture you say you have to give me an estimate that is correct, otherwise you will lose your job, what's going to happen is people are going to go and actually pad their estimate and they're going to give you whatever you want. They will get it done on time, but that means you're wasting a lot of time along the way. So the culture. Other factors, you might plan to go and deliver something within a week, and then you come in and there's coronavirus and everybody's staying at home for that week. Non-project factors, again, influence the quality of our estimates. So how should we really estimate how long a project and a task needs to go and take us? Well, the best thing to do is you need to have people who know about these things, okay? Have people who are actually familiar with the tasks to be able to go and estimate how long that task is going to actually take. Instead of using one person to give you the estimate and one person could make a mistake, why don't you use more than one person and try to get these people collectively to go and make an estimate about what they believe things are going to go and take, how long they're going to take. When you want to go and tell people to make an estimate, tell people to make an estimate based on normal condition, not based on I'm going to work overtime or I'm going to work very efficiently. Just a normal base estimate. How long is it going to take me to go and get this outcome to be delivered? Use consistent time units in estimating task times. For example, don't estimate some people by using some tasks by using days, and you know, use other estimating to do hours. Use consistently. If you're going to use days, use days. If you're going to use hours, use hours. But the unit you are going to be using needs to go and be done in terms of consistent estimation. When you want to estimate tasks, there will be so many tasks in your work break and structure. Now, don't estimate these tasks in a way that you think they are connected. Don't estimate, well, because this task and this task are connected, I'm going to reduce the time it's going to take. No, this task that you need to do is by itself. You estimate it by itself. This task that is by itself, you can again go and do it by itself. You don't say, well, they are related, I'm going to go and estimate them together. No, you don't combine the planning of the tasks. Don't make allowances for contingencies. Like, don't say, well, if this happens, I'm going to go and add extra time just in case. No, just base it based on normal conditions. What is it going to be? Don't add, don't pad. Add a risk assessment, which helps avoid surprises to stakeholders. If there's something that you believe might happen along the way, it's a good idea to go and have assessed those risks so that if they were to happen, you know exactly what will happen and you are already prepared on how you are going to deal with it in case that issue was to actually go and happen. So when we talk about all of these estimates, there's a top-down estimate and there's a bottom-up estimate. Top-down estimate is derived by someone up there, have the experience, have knowledge, have information. They determine, for example, how long the project is going to take. It's usually made by top managers who have little knowledge of the task that is needed to get the job done. So they are up there, but they are estimating how long your project is going to go and be taking. There's another type of estimate called a bottom-up estimate. Can serve as a check on cost elements in the work breakdown structure by rolling up the work packages and associated cost accounts to major deliverables at the work package. So you go all the way down to every single work package. What is a work package? It's a package that you will go and assign. If you want, in simple words, it is a task that you are going to be assigning a person to get the job done on a project, and it was going to go and consume time. Because it's going to be consuming time, because it's having someone assigned to do that job, it is going to cost me money. So in a bottom-up approach, we go to every work package or every work task that is needed to complete the project, and from there we estimate the time of each one of these steps to be able to go and reach a proper estimate. That's what we call a bottom-up approach. Don't tell me build a house and give me that estimate. No, tell me, what am I going to be doing in the house? Okay, I'm going to sort the garden section A. I'm going to go and paint the house. You need to be very specific. Okay, and every painting the house, what are we going to be doing? Okay, you have to estimate that. So you're going to go to the very detail, and you're going to go and estimate the detail. Now, bottom-up estimating and top-down estimating are both important, are both beneficial. Okay, when I talk about, if you want top-down approaches, it's basically what we call macro estimate. It's high-level estimates, and they're good. They're good for strategic decisions. They're good when there's a high uncertainty. They're good when it's an internal small project, and they're good when the scope is unstable and it is actually bound to keep on changing. But when is a bottom-up approach better? When do you need the details in your analysis? Well, when the costs and time are important and we need to go and manage them. When there's a fixed term contract that the person is going to pay me that amount, whatever happens, I can't go and make an estimate and I'm not 100% sure about that estimate, because otherwise I won't make money. I have to make sure I'm very, very clear on what I'm actually going to be doing. When the customer wants you to provide them with the details, if they want you to give them the details, it is then your job to ensure you are going to go and give them those details that are actually being expected. So bottom-up approach and top-down approach are both good approaches, but you need to think about when they are needed. And guys, they will both be needed at various points of time. Alrighty, guys, I'll make another quick check to make sure everybody is clear. Do I have a thumbs up there? I can see 1, 2, 3, 4, 5, 6 out of 23, 7, 8, 9. Ronish, yep. Okay, getting more people now. Okay, Rakesh, Damang, all good. All right. Now, guys, it's probably a good time now to say, I hope you consider me maybe part of your small family here in Australia. For anybody who celebrate Diwali, I just want to say happy Diwali to all of you. I hope you actually enjoyed it. I hope you all guys will have a good blessings now and in future with all your families. I know it's hard to be back away from home, but we are your extended family here in Australia. So happy Diwali for you guys, for those who celebrate it. Now, if we go and talk about the estimating, what's the preferred approach we should follow to go and make the estimation, guys? Well, the best approach we do recommend is the following. One, you make a rough top-down estimate. So you come and you allow this manager to be able to go and make a top-down estimation with all of that information. So you make a top-down estimates, and then from there, you go to the details and you create a detailed work breakdown structure, a detailed organizational breakdown structure. And what will happen there when you do it is it will ensure you have a very clear information about who is doing what if that's a work breakdown structure, if these are the tasks, you basically have the organizational work breakdown structure, which says who is going to be doing which task. So when you do that, when you create a work breakdown structure for the detailed work of how we're going to get things done, when you create the organizational breakdown structure, who is going to be doing what, you're going to be able to have what we call a bottom-up estimate. So you're going to be able to have a clear estimate of how long and how much each task is going to actually cost me. So you start with a high level estimate, you create the work breakdown structure, you create an organizational breakdown structure, and from there, you start making the bottom up estimate. You start estimating each one of these tasks in the work breakdown structure that could be assigned to a specific person. This will help me to go and develop the schedules as well as go and develop the budget. So we can actually go and work through that. We have the budget per month, per week, whatever needs to be done. Then what you do, once you have a bottom-up estimate and a top-down estimate, you try to reconcile them. How different is a top-down estimate from the bottom-up estimate? If they are very different, you'll try to basically make the comparison to these things together, and you try to go and get a proper estimate. Now, this is the best approach to estimation. That doesn't mean that that is how people usually always go and estimate. But saying that, that is the best approach we need to go and think about when it comes to how do we go and create our estimates. The top-down approach to estimation, how do we do it? Guys, there's a consensus method, there's a ratio method, there's a apportion method, there's a function point method, learning curve method, just to name a few. Consensus is where you might basically go and put a number of people together in the actual room. It could be senior managers, and what the senior managers go and do, they'll go and say, all right, let's go and make an estimate for this specific project. So you'll go and they'll start discussing all of these details about the project and so on. Then all of these people together, senior managers, they don't do the job, they don't have the experience about doing the job. They'll go and say, okay, what I'm going to do is I'm going to go and we're going to make a consensus. We believe this project is going to cost me $2 million. They haven't planned it. They haven't looked at the task. They haven't done any of that, but they went and tried to go and get this consensus on what it's going to be. A ratio method is a method where you will really go and look at high level. For example, you go and say, okay, I'm going to go and do a software development project, and that software is going to go and take me 2,000 hours of work. Okay, great. 2,000 hours of work. How much do we charge per hour? We charge $300. All right, perfect. So 2,000 hours of work. Perfect. And then on top of that, what I would like to do is I would like to go and multiply that by the $200 an hour that we charge. And we know that we're going to go and say this project is going to cost us $400,000. You do it based on a ratio. That's per day. That's per hour. That's how much we charge per hour. That's it. You know, we go and get this ratio method. A portion method is more about, you kind of make it based on percentage. You say, okay, this software development project is 100% of my work. I'm going to divide it by 30% hardware, 40% software, 40% database. That's 100%. And if I say the whole project will cost me $1 million, then if I say hardware is only 30%, that's mean the hardware is going to cost me $300,000. If my hardware is 40% and my database is 40%, that's mean my database will cost me $400,000 and my hardware is going to cost me $500,000. That's what we call as the apportion method. We divide that high estimate to very specific small portions. The last one is a function points method for software and system projects. So the way that it works is you think how hard, well, actually first you think, what do I need to go and deliver for this project? There's inputs, there's outputs, and so on. What you do from there, you go and say, okay, I know what I need to go and deliver. How hard is it going to be for me to do it? Well, some tasks are easy, some tasks are hard. Based on all of these calculations, you get what is known as a function point. And from there, what you do, you'll be able to go and know how much you are going to be charging for the whole project based on how much you charge per function point. And finally, there's a learning curve. So in the learning curve, we go and make an estimation based on what we know will happen, because we will be able to become better at doing a specific job. So what we do, ladies and gentlemen, is we go and say, all right, so if I usually go and say a task will start, if I need to go and work 100 hours, if I know the first hour will take me an hour, but then after that, it's going to start taking me less time, the learning curve enabled me to make an estimation about how long the overall duration is going to go and take me, by considering that some tasks I will actually become better at actually doing. I'm going to cover some of these methods now, but do you guys have any question? Is what I've explained, does it make sense? Anything unclear? Okay.
Hello, sir.
Yes, my friend.
Sir, this is my first week. Actually, they gave me the subject last week. And
Yes, Japneet.
they gave me the subject this last week. So
Yep.
I missed my 2 lectures. So
Okay.
I already watched 1 lecture completely, but I'm a bit confused with the tutes. So maybe I will need some help with the tutorials.
Are you in tutorial 1 or tutorial 2?
In 2.
Okay, perfect. So we'll actually have a chance to talk in details today. Not to worry, if you continue to come to my lectures, you will be able to go and understand what needs to be done, especially today, because this is really where the very, very important stuff starting this week. So stay with me, you'll be fine. I promise you that.
Thank you so much, sir.
Do not worry, okay? Finger crossed.
Okay, sir. Thank you.
We'll be well.
Thank you, sir.
Thanks, man.
Thank you, sir. Thank you so much.
All right, so guys, the apportion method is what I've just explained to you. Okay, the apportion method is what I've explained for you guys. There's a total project, it's $500,000. I say, okay, let's look at the percentage. 20% design, 30% program, and so on. Okay, 500,000. What's 20% of that? It's $100,000. Perfect. Out of this 20%, 50 of it will go here, or if you want, out of this 20, 10 is here and 10 is here. That's mean this 100,000 is divided between 2. This will cost me 50 and this will cost me 50. That's what I call the apportion method. 150,000. Why? It's 30% of 500,000. Split it by 20%, 5%, 5%, 20% of the 30% of 150. That's 100,000. 5%, 5% of this 30%. Then that's 25 and 25,000. So that's how we do the apportion method. The function point. I have all of these inputs, outputs, inquiries that I need to go and think about. All of this is relevant. All of this is important. So what do we do with that? Well, what do I do with that, guys, is I go and think about all of these inputs and outputs that I need to generate. I thought about them. That's great. So what do I do then? Well, after I actually did that, I need to go and start thinking about, if you go and think here, I want you to think, okay, there's 15 inputs. Yeah, perfect. So how complex are they? Well, they are not very complex. So we basically count them as a 2. 15 times 2 is a 30 function points. Okay, we have outputs, 5 of them. Perfect. How much is each? It's 6. Okay, perfect. So 5 times 6 is 30. We have the third one, 10. All right, perfect. 10 times 4. Okay, perfect. That's 40. So you calculate all of these function points. And eventually the overall will be 660 points. So based on these 660 function points, you'll be able to go and start, if you are making the estimation about how long the project is going to go and actually take and how much is it going to cost you. You say, okay, for example, every 10 function points will cost me 1 week. Or perfect. So 660, I need 66 weeks. Okay, every week I charge $10,000. Perfect. So 66 weeks, $660,000. So you can kind of start taking all of these estimation. Now, ladies and gentlemen, all of these top-down estimates are great. The advantages are the overall project budgets can be set and controlled very accurately all the way from the beginning. Management has more control over the budget. Do not need so much upfront planning. We don't need to waste our time planning, looking at the information and so on. But if I go to say, Let me, okay. Guys, tell me about any tasks you guys do at work, something you do regularly at work, a regular task. What do you do at work? Give me a specific task. Salur. Salur? Salur, can you hear me? Salur, can you hear me? Okay. Okay, guys, who works at the moment? Who does something repetitive at work at the moment?
Any type of work
Sir,
or specific work?
Who's that? Ali?
Yes.
Okay, Ali, what do you do something consecutive? You always do the same thing. What is it?
To baking pies.
What's that?
Baking pies.
Baking pies. Okay. How long does it take to bake the pies?
34 minutes.
Do you bake good pies?
Definitely I am.
Definitely. So are you going to invite everybody in the class for your pies and we can make the judgment?
Yep.
You know, we should actually go and eat the pies and say they're not very good. Do you know why? Then you'll give us another pie. That'll be good. Okay. My friend, how long does baking the pie takes?
34 minutes, sir.
34 minutes. If I come and say, all right, Ali, you know what you want to do for me? Are you ready for it? I need you to bake the pies in 20 minutes today. What are you going to say to me?
It's impossible.
What, Ali? I don't care what you're saying. I need the pies in 20 minutes. Why is it impossible?
Because it's specifically designed to bake in 34 minutes, not more, less than that.
So are you going to be happy if I come and impose on you and say it has to be done in 20 minutes? Are you going to be happy?
No way, sir.
You're not going to be happy because I'm imposing on you something that I do not know about. And this is the same thing when you are making a plan based on management doing that plan. A manager wants to save money. He wants you to work more. He wants you to get more money for him. Bake more pies. But you can't bake more pies. You can't. It's going to need 34 minutes. So it is more difficult to get buy-in. The people who needs to go and do the job won't very easily say, okay, no problem. We're going to go and accept it. They're going to say, no, we're not going to accept that because it is going to take much longer. Disadvantage is leads to low-level competition for larger share of the budget. People start competing. Okay, we want more budget for ourselves. We want more. And basically, departments might basically start giving different estimation to be able to get more budget. There's no detail available about how we actually came to this conclusion. How much is it going to cost me for a particular specific task or a specific project? There's no contingency added. We don't know the extra. What if something goes wrong while we're trying to go and make the estimation? Don't we need to go and have an estimate about all of these things that could go wrong? We haven't thought about any of that in top-down estimates. Okay, Salur, are you live with us in the classroom? Salur Katka, are you live with us in the classroom? Okay, my friend, please stay with us and don't go anywhere. Focus, okay, my friend, because this is really, really important for what I'm going today in the tutorial. So please be 100% focused. Now, the bottom-up approach, they're basically a bit different. You want to go and try to get details from the beginning about the costings. There's a template method. Someone comes and give you a whole template from the beginning all the way to the end and say, I would like to go and have this specific estimation. That's fine. That's one way for us to go and do that. Parametric procedures. It's really similar to the ratio method, but instead of the ratio method being on a higher level, like the house is going to go and cost me, you know, $1,000 per square meter and I have 100 square meter, you're going to go to the details. You're going to go, okay, this is my big house. This is my big software. Let's think about each area. Let's think about business analysts. Let's think about testing. Let's think about development. Let's think about project management. Okay, you go to detailed about how much is each of these area going to cost me, not the high level area, each area within my project. Okay, I need 100 hours of project management. Each hour of project management will cost me $100. That's $10,000. So you go to the detail of each specific things that is going to be needed when it comes to getting the bottom up estimates. You can create a range of estimates. This is what we call the PERT method. You know, optimistic estimation, pessimistic estimation, most likely estimation, and we go and use a formula to be able to go and decide on how much something is going to go and actually take me and cost me. There's also a combination. I might be using, for example, some of these methods here together. I might be using bottom up and top down approach together, just to name a few. But if we think about this estimation, okay, low estimate, this is what we call the PERT method analysis. This is what we call the low estimate, most likely estimate, optimistic estimate. And the way you calculate it is you use a formula. You want to know how long is it likely to actually take me for let's say the approval? Well, let's think about it. The low estimate is 1, the most likely estimate is 4, and the optimistic estimate is 5. So the way that you do it is what we call it 1 times low estimate, so 1 times 1, plus 4 times average estimate, so plus 4, 4 plus 1 is 5, plus 1 time high estimate, okay, so 5 plus 3 is 8, perfect. You divide that by, this is 1, so 1 times 1, 4 times 1, and 1 times 3. So what you do is 1, because you're multiplying by 1, you're multiplying by, 4 times most likely, and this is you multiplying that by 1. So 1 time 1, so that's 1, plus 4 times most likely, 4, plus 1 time optimistic, so that's 6, okay? So the total here is 8. 8 divided by 6, you basically know that the estimation is more likely to be around 2 days in terms of your estimation. So 1A plus 4 times B plus C will give me the average. So calculate it, guys, in front of you, okay? 1 times 4, just add it in front of you. 1 times 4, okay, plus 4 times most likely, so 4 times 7, plus the optimistic, which is a 12, divide that by 6. For this one, you get the answer of 7.333. And then that's basically an approximation of it's going to be 8 days for me to go and finish that task of design packing.
Sorry, sir. Could you just repeat that again?
Okay. So the formula is 1 time, so 1 multiplied by low estimate. So 1 multiply 4. Write it. What's that in front of you? 1 time, 1 multiplied by 4. What is that?
4.
4. Plus 4 times average. So 4 times 7. What's that?
28.
Plus 1 time high estimate. So plus 1 time 12. What's that?
12.
So you add all of these together. You divide them by 6. That will give you the average estimate for that specific activity, design packaging.
Sir, why did we divide by 6?
Because there's, okay, I said 1 time plus 4 times, that's 5, plus 1 time, that's 6. So you're getting the average. The average is, if there's 1 here and 4 multiply here and 1 multiply here, 1 plus 4 plus 1, that's 6. That's why you divide it by 6. This is called the PERT method of estimation. Does that make sense?
Sort of. Still confused.
No, sir.
6.
I'm confused.
The 6.
Okay,
Yeah.
let's do it again. Okay, guys, I am multiplying 1. Okay, 1 times 4. Yeah. So how many times I'm multiplying? I'm multiplying it 1 time. Plus 4 times this. So in addition to the 1 that is I'm multiplying at the beginning, I'm multiplying 4 times the second number. So I add 1, 2, 3, 4. That's 5. So 1 time plus 4 times, that's 5. Plus 1 time high estimate. So in addition to the 5, there's a 6. So to get the average of this number, you have to get the totals of these multiplications. You divide them by 6 because 1 plus the 4 times plus a 1, 1 plus 4 plus 1, that is a 6.
Is it always going to be 6?
Yes, in the PERT method of analysis, that's how it is, yes.
Okay, so it's always going to be 6 in this sort of analysis. So if it's the case for, let's say we're trying to estimate the approval, then that would be 1 times 1.
Yep.
Plus 4 times 1.
Correct.
Plus 3 times 1.
Correct. 1 times 3, yeah. Divided by?
3 divided by 6.
That's it, brother. Well done.
All right.
It's a very simple method. Clear? Are we clear? All right, great. Let's move on. So advantages of a bottom-up approach, guys. It's a greater buy-in because you estimated it. You'll say, yeah, I'll do it. I told you how much it's going to take me, and I'll show you I can do it. Because we're estimating in detail, it's more likely we're going to be able to catch unusual expenses. The disadvantage, however, people tend to overstate their budget requirements as padding. They'll say, okay, it's going to go and take me a bit more. That might be an issue, and that's fine. That could happen. And management tend to cut the budget. So I say, okay, I'm going to add more. Budget comes and cut my budget. I add more. The management cut my budget. So there's all of these conflicts that might actually go and happen when using that process. So how much details do we really need, guys? We need to think, look, too much details will cost me money. Okay, it forces focus on detrimental outcomes. It creates unproductivity. It creates paperwork because we're creating so much details. But if you go and have no details, there's no focus. There's a weight of efforts on non-essential activities because I haven't estimated, I haven't planned. You know, all my information planning might be wrong. So I don't know about it. I haven't actually planned the right information. So you need to go and really think about creating an average level of details that is appropriate for whatever the project you have on hand. Not too much details, but not no details at all. Create an average that works for everybody. When you talk about a project cost, you talk about a lot of costs. You talk about direct costs, direct overhead costs, general and administration costs, and so on. Direct cost, costs that I can clearly charge to a very specific work package. For example, I'll say, all right, you need to go and install the carpet, or you need to go and write a line of code. That's my labor. I need to include it. I need to go and buy the software to test the actual computer. That's buying the software is going to be costs that I need to go and do to be able to get the job done. It's a direct cost associated to do specific work on a specific work package. Direct overhead costs, costs incurred that can be tied to project deliverables or work packages. We could potentially tie it. For example, I'm renting a space to be able to do the job. I'm getting supplies to do the work. I have specialized machinery that is needed to get the job done. I have a supervisor, a project manager who I need to go and pay to get the job done. It's really an overhead cost. The project manager might be managing the overall thing, but not actually working on the package himself, just overseeing the whole thing. There's a general and administrative overhead costs, organization costs indirectly linked to a specific package that are apportioned to the project. For example, you might go and say, I need to go and create a You know, I have, for example, a project management office in the organization. This project management office tends to go and create a lot of reporting, a lot of development for how do we do project management better. They teach us, they do things. What is that? Well, if I have 10 projects and if we go and have this project management office costing us $10,000 a month, we split that $10,000 alongside all of these projects that are running at any point of time within our organization. So all of these guys are really go and link together. Now that brings me to the end of the first part of what I'm going to be covering today. And now we're going to move to the second very, very important part that is linking really to that first part. And it's really important to understand how do you make those calculations that I'm going to start explaining today. The calculations I'll explain now are equally important for your quiz, your midterm exam, and your final exam. You miss those foundations, you make your job very hard. So please pay attention. We need to create, when we create a plan, we create a project network diagram. What is a project network? Guys, it's a flow chart that uses the work breakdown structure and graphically depicts the sequence. You know, what's going to happen first, what's going to happen next. The interdependencies, the start and finish times of the activities throughout a project networks. It really, if you go and create all of these work breakdown structure, if you know who's going to do them, when they're going to start, when they're going to end, what's first, what's next, this is really all comes part of the network diagram, which you'll see very shortly, because I'll show you a work breakdown structure and I'll show you how do you transfer it to a network diagram. The network diagram is very, very important. It makes us have the basics that are required to be able to schedule labor and schedule equipment. It will make us able to better communicate among project participants. They know what they need to do at any point of time. They can see their names to it. They can see their written sign. They know what time they need to start the job. They know what time they need to finish the job, because all of that information is very clearly identified and mentioned for them. It provides an estimate of how long the project is really going to actually take me. If we know the first task, if we know the last task, if we link these tasks, what starts, what ends, and so on, what comes first, and so on, you will find that at the end, you know how much a project is going to take you. Not simply you know how long the project is going to take you, but also you know how much is it going to actually cost you at each phase of the project. A phase could be an initiation stage, it could be planning stage, it could be execution stage. You could know how much it's going to cost you each stage. You can even go into more details. You can go to, if each stage have sub-stages in it, you can know how much each sub-stage is going to go and take you and how much is the cost and time. You can know which activities we call to be on the critical path. When I say an activity is on the critical path, means this activity is one that cannot be delayed, because if I am going to be delaying it, it is going to go and delay the overall duration of my project. So any activity that is on a critical path that gets delayed will affect my ability to go and get the job done. We highlight activities that are not critical and how long can we delay them. For example, some of the activities that we need to do are not on what we call the critical path. If they're not on the critical path, which means they have something called slack. Slack is something that I will teach you how to calculate. Slack will allow you to know how long an activity could be delayed without influencing on our ability to be able to go and get the job done. Highlight activities that are not on a critical path, and simply it helps the managers to really remain part of the plan. So if we know, for example, a task needs to be done within 2 days, day 1, day 2, day 3, whatever they are, we'll be able to go and understand when, whether we are on time, whether we are on budget or not. If we're not, we can take the action. If we're not on time, we can take the action, because we know that this activity should have finished in let's say day 5, and it's day 10, and it has not been finished by that specific time. My friends, I could very much appreciate now a very quick thumbs up if you guys understand what I'm explaining so far. Okay, Ranish, Arjun, Muhammad, Ali, Devraj, you guys can hear me?
Yes, sir, all done, all done.
Perfect. And one more person, Rakesh, are you here, my friend? Is Rakesh here? Dear Rakesh, our friend. Okay. If anybody knows Rakesh, please message him, because what I'm covering is really, really important. If he can't do that, he can't do the exams, he can't do the midterms, it's going to be a problem. So if anybody is in Rakesh's group, please message him now, because this is really important. So guys, we spoke last week about what we call the work package. I told you the work package is a job that we need to go and do. So you think about, I have a design cost account, I have a production cost account, I have a testing. So there's design work, there's production work, there's testing work, there's software work. Okay, great. So what is the design work we need to do? Well, the work package, in other words, the work I need to do is I need to do the specifications and I need to do the documentation. Great. What about production? What is the work that I need to do there? Well, for production, I need to do prototype and I need to do final prototype. What about the testing? Oh, I need to do test work. What is the software work? I need to do software preliminary work and software final version work. Now that's awesome, but that's missing. You need to ask yourself, okay, I know all of these tasks that I need to do, but your question is, what should I do first? What should I do after? I cannot test first, then create the prototype. I have to create the prototype first, then I have to go and start doing the testing at the end. So you need to know not simply the activities that you need to do or the work packages you need to do, but also you need to know about when do you need to go and do them. Specifications, one. Then I do the prototype, I do the preliminary software. That happens after. Then after I do this, I get my final prototype. Then after I get my final prototype, I'll get my final software. And after I get my final software, I'll do my testing. So you go level by level, step by step to know what should actually happen first and what should actually happens later. Now, this here, these foundation, these items here, these arrows, these items, these arrows this way or arrows that goes this way, you know, this arrow that is starting here and going to 2 boxes is different than this arrow that is coming from 2 boxes and going into 1 box. There are names for these arrows. We need to tell you what they are. So these sort of boxes, they are what we call an activity. It is an element of the project that actually requires time. It will take me time to go and complete. This activity here, because there's 2 arrows going to it, we call it a merge activity. Any activity that has 2 or more preceding activities on which it depends. So D depends on A and B. They merge in D, and then from there we'll be able to start working on that activity. Some activities are parallel, which can actually start working on at the same time. They are independent. I can work on A and B at the same time. I can work on A and C at the same time. That's something we go and bear in mind. We talk about a path. Path is a sequence of connected dependent activities. In one of the chapters, you will need to really develop and talk about the paths, and that's what people tend not to do very well when it comes to the exams. In here, there's 1 pass, AD, there's 2 pass, BD, and there's a 3rd pass, BC. On here, there's
So,
1. Yep.
Constructing a project network means to like manage all the employees
It's really more about creating a visual representation of all of your activities, when they are going to be happening, and based on finding the connection between all of these activities, identify which activities cannot be delayed and have to happen by a certain time.
Okay.
Okay, does that make sense? Should I repeat it?
Like in database, like we used ERD, here we use constructing a project network like this.
Well, I don't know about the RD, but what we're doing is you are basically trying to create a visual representation about how all of these tasks of the project are actually connected together. Okay? When you know how every activity of the project is connected together, you'll be able to go and know which ones can be delayed and which one cannot be delayed. The one that cannot be delayed, these are what we call the critical activities that we need to manage. The one that we can delay, they are basically called the items that are non-critical and have a slack that we can go and delay accordingly. I will be talking more and more, and you're going to have to apply what I'm teaching you. So you will understand more and more about the network diagram when you start applying it yourself and when you start seeing how it actually looks like a bit later today in the activities that I'll show you very shortly. So if you don't understand it, Ali, after I show you, could you please ask me that question again?
A and B represent what?
Well, A and B represent activities that I need to go and work on to complete the job. If, for example, I tell you, I want you to go and cook for me a meal, A could be, let me buy the ingredients. B could be, let me cut the ingredients. D might mean, let me make the cooking. E might mean, let me finish the actual cooking. So these are activities that will consume time that I need to assign people to go and work on to complete.
Okay, so these diagrams show that every task we should assign to particular person, and a critical task must be like do as early as possible.
Well, yes, correct. So as simple as that. The critical path is those activities that you cannot delay. If you delay them, your project will be delayed.
How we know that this
That's what I'm teaching you. I haven't taught you that yet. This is the introduction, but that's what I'm teaching you today. Okay, so this is just, I'm only introducing the basic concepts, and I'm going to go and explain to you every other concept, the network diagram, the critical path. I'll explain all of these for you. I haven't done them yet.
Excuse me, sir.
Yes.
Sir, in parallel activities,
yes,
the sentence if desired, not at the same time.
Yeah. So let's say, so you can do activity. Okay. Let's say, for example, you want to clean the house and you want to cook. Okay. You can clean the house and cook maybe at the same time. Okay. But you don't have to clean the house and cook at the same time. Okay. If you choose to do them at the same time, that's fine. But that doesn't mean you have to start them at the same time.
All right, sir.
Does that make sense?
Yes, sir.
Okay. Any other questions? Ali, any other questions?
No, sir. No, sir. Thank you. Please
All
write
right.
to go.
That's okay. So let's continue and ask me the question again. If you're still not clear, I'm going to explain that in more details very shortly now. Now, you know what? Before I actually continue, because I usually give you guys a break around this time, what I'm going to do is I'm going to give you 10 minutes break and then we'll continue back in 10 minutes. So have your break, guys, and then I'll continue in 10 minutes with the remaining. I hope you guys had a good break. Let's continue with explaining all of these terminologies. What is the critical path? The critical path is the longest path through the activity network that allows for the completion of all the project-related activities. In other words, it is the shortest time it is going to actually be taking me to be able to go and really complete the project. If any activity on the critical path is delayed, the entire project is going to actually be delayed. And we'll talk more about that very shortly. I'll show you examples and you know what I'm talking about through the examples. Events or milestones. It's a point in time when an activity is started or an activity is completed. It does not consume time. For example, if I tell you I want you to go and write module 1 coding and I want to finalize it, you make the development, you write the coding, you write the actual bug editing, you do the testing, and then you go and after that you try to go and actually release it. So what you do is, if you talk about development, if you talk about testing, if you talk about all of these activities, they are going to consume time. Development, someone need to sit down and make a development of a case. Testing, somebody will need to sit there and test the module. So these are what I call activities. But after I finish all the work for module 1, after I do the testing, I do development, I do analysis, I do coding and so on. After I do everything, what happens? The module 1 will be complete. So what I do is I write in the project, in my plan, I write module 1 complete. Now, module 1 complete is not an activity. It doesn't consume time. No one is doing any job. We're just telling you it is completed. That's what we call it's a milestone. It's just basically telling you that something has been completed. That's a milestone. It consumes 0 time. It's a 0 days duration. A burst activity is an activity that has more than one activity immediately after it. So if I go and say on a network diagram, there might be activity A here, and if after there's activity B and activity C, then this is what we call, this is a burst activity, okay? There's from that activity, which is A, 2 activities are bursting, one going on one side and one going on the other side. The basic rules to follow in developing a project network. Now you need to know that when you start building a network diagram, it starts from left to right. You need to know that an activity cannot start until every activity before it has already started. You need to know that the arrow indicates what's before you and what's after you. So if I have A and there's an arrow from A to B, that's mean A finishes and then B has to start after it. Each activity must have a unique identity number. So you number it 1, 2, 3, 4, whatever they are. And every number should be higher than the number before it. Looping is not allowed. So if there's activity A, B, C, D, E, you can't go and do D and then go back to do A after. There's no looping. You start it, then you do the next activity. You can't do conditional statements like, if B does that, then I'm going to go and make A again. No, you do A, you finish it, you move on. You can't say, if this happens, I'm going to go and do something else. That's not what you do in the project. You use a common start and stop nodes. Common. So we start with a common at the beginning and we end with a common at the end activity. So if you want to know where to start, you start with, it's like you make a circle, that's your start node. You can do that. And you can make a circle, that's your end node. But that node is not really an activity. It's simply linking all the activities together to the end. You can do that, but we're not going to do it too much here in the actual calculations, as you'll see. So let's try to go and think about all of these things that I explained to you. You can see there's A, there's an arrow, there's B. That's mean A must be done before B starts. B starts after A is completed. A, there's nothing before it. C, there's before it B. So C is preceded by B, B is preceded by A, and there's nothing to start before A. Here you see, okay, there's one path, XY, and one path, XZ. Y and Z, what's before them? X, they're preceded by X. Y and Z, they are parallel, which means Y and Z could start at the same time, but do not have to start at the same time. We can if we want to. X is a burst activity. Why? Because there's one activity and there's 2 activities coming from that specific one activity. If we look at this one, I have JK and L who are parallel and all could start at the same time, but they do not have to start at the same time. And I can only start M after all the activities JK and L has been completed. Once they're finished, then I can start M. M is a merge activity because all these activities are merging into that activity. Z, what's before it? X and Y are before it. And AA, what's before it? X and, sorry, AA, again, X and Y is before it. You can see there's a box from X and there's an arrow from Y. So there's bursts of them. X and Y could start at the same time if we want to, but don't have to start at the same time. In here, there's one pass, X, Y, Z. There's two pass, X, AA. There's three pass, Y, Z. And there's a fourth pass, Y, AA. So there's more than one road that we can go and do here. Now, guys, have a look in front of you. Can you please tell me which activities needs to be done first? Which activity happened first, guys?
A.
Okay, can you draw A, guys? All of you, could you draw A in front of you now as one of the activities and give it a duration of 5 days? So draw it in front of you now. A is going to be the first activity. There's nothing before it, and it's a duration of 5 days. Once you're done, give me the thumbs up.
So every time we have to start from minimum days.
Every time you start with the first activity in your project.
Okay.
Okay, and that's in this example, the first activity. So guys, there's some people who didn't give me the thumbs up yet. I asked them to draw A, so please show me the thumbs up to know that you've already drew it. Pranahitha, have you done it? Pranahitha? Guys, anybody in Pranahitha's group? Who's in Pranahitha's group, guys?
Me, sir.
Okay, could you message her, please come to the classroom? Tell her the teacher said you're not in the classroom and this is really, really important. So please get her to come to the classroom.
Okay, sir.
Thank you. Okay, guys, after A, what's going to happen? Which activities do we do after A?
B, C,
B,
and
C, D.
B, C, and D. Perfect. Can you draw me after it? Could you make an arrow from A to B, from A to C, from A to D, and put B, C, and D on parallel on top of each other? Draw it now in front of you, and once you're done, please give me the thumbs up.
So first activity is A, and then.
So activity A, there's nothing before it. Then there's
Then
activity
E,
B, C, and D, and it's telling you there's A that is before B, C, and D.
There,
So,
there are three lines generated from A, which
correct.
is B, C, D.
Correct. Now, anybody who've done B, C, and D, I need you to draw the remaining network diagram. Draw it all now in front of you. Anybody who haven't drawn B, C, and D, draw that and then draw the rest. So finish the whole network diagram. And once you're done, I want to see the actual information.
Then from BC, we have E.
So there's B, C, and D after A, and then there's E which comes after B and C, and there's F that comes after B, C, and D. So you need to look at that and draw it accordingly. So once done, give me the thumbs up. Yep, thank you, Aisha. I'll just wait for the rest. All right, so I have 2, 3. Ali is finished. Yep. All right, Kevin is finished. I can see so many people are finishing. Asha, Binay, Adudodla, Sanjay, Pranathiva. Is Pranathiva back or no? This is not the first time Pranathiva is not here. Okay, so I'm gonna now show you that. Did you guys get that? Just have a look at your diagram. Is that what you guys have drew? Anybody made a mistake?
Similar.
Similar? Okay, perfect. Are we good?
A, B, C, D.
Yes, sir.
Okay, so basically you're telling me, you asked me, Ali, earlier, you said, what is a network diagram? So what I'm telling you is basically this, okay? So what I'm telling you is these are all the activities, and you are making the activities as a graphical view, so you can see it how it is here graphically, rather than as a task from A to D. And once you make all the calculations, which, by the way, the system will calculate for you on Microsoft Project if you use it. Once you do all of these things, you'll be able to know how long the project is going to actually take you. You'll be able to know what is the actual critical path.
Correct, critical.
Does that make sense, guys? Give me the thumbs up if you're clear. Binay, Sanjay, Arjun.
So what is legend mean here under the A?
Okay, legend is how we are drawing it. So we're gonna draw soon what we call, this is ES, mean early start, which is you put it in this box. EF is early finish, which is what we put in this box. LS, which is later start, you put in this box. LF, which is this, you put it in this box. This is a description of the activity. This is here the duration, 5 days, duration of the activity. So it's telling you how do you actually go and draw that information. Does that make sense?
Yep.
Okay, so we'll start making the calculations now here. So we need to make the network diagram calculation. There's what we call a forward pass, and there's what we call a backward pass. Forward pass, what is the actual earliest time an activity could start? Early start time. EF is early finish. How soon can the activity actually finish? How early is it possible for the activity to be finished? Estimated time is when do I actually expect to go and get the item to be able to be completed. So you see here, this is what I call early start. That's what I called early finish. And the last point of the project, this is what we call the estimated time of completing the project. Then we have the backward pass, which is a later start. How late can the activity start? There's a latest finish. How late can the activity actually finish? And there's which activities represent what is known as the critical path, and how long can an activity be delayed for. This is what we call the slack. Now we're going to make the calculations. There's also what we call total slack, which is the amount of time an activity can be delayed and not delay my project. And then the last one is free slack. It's how long an activity can exceed its early finish date without affecting the early start date of any successor. So if I look here, if the slack here is 1 day, And if you go and that one day won't actually go and affect the duration of the next activity, this is what we call here, we're calling on the free slack. So there's activities that have a slack which would impact on the overall project. So it will basically, if I have that slack, how long would that amount is without delaying my project? And when I'm talking about free slack, it's when you have two activities that are behind each other, and it's if I delay an activity one without delaying the other activity after it, that's what we call a free slack. So if activity B is 1 day delay, and if I delay that activity by 1 day, the activity C behind it won't be delayed. That's what we call free slack, which is two activities behind each other. A delay in one activity will not delay when the next activity is going to be starting. There's also the concept of sensitivity. And what I mean by sensitivity is the likelihood of the critical path, becoming an issue. So sometimes you have one critical path and you might have another path and in that other road or other activities that you need to go and do, there's only 1 day of slack. So if there's another road and other activities we need to do for the project, and there's the first road we need to do for the project, if the second road only have 1 day of slack, it's mean what we call it is a sensitive path, which means if that 1 day is delayed, I will now start having not simply one critical path, but I'm going to have two critical paths. When I say about the actual path, look here. A, B, E, H is one path. A, C, E, H is one path. A, C, F, G, H is one path. A, D, F, G, H is one path. If, for example, A, B, E, H is a critical path, and if A, D, F, G, H only have 1 day of slack, if this day of slack is gone, then I have this become a critical path, and this also becomes a critical path, because this was what we call a sensitive pathway in my project. So A, D, F, G, H is a sensitive path. That's why we go and we have to really manage that path that have very little slack on the way. Now, I'm going to start implementing this and it will start making more sense. Now, the way that you calculate it, and this is please very important, you focus, you add activity time along each pass in the network. That become your early start. You add the duration to it, and that will give you the early finish. So this here is the beginning. So the day 0 will start in day 0. That's the early start time. 0 plus the duration of 12 days give me an early finish of whatever early finish it's going to be. So early start plus duration gives me early finish. Then my early finish becomes the early start for the next activity, unless there's rule 1 that I'm going to explain in a second. So the early finish here goes there and becomes the early start of that activity. So if this activity finishes in day 12, this activity could start straight after day 12, and then you go and 15, and then you basically add it, it becomes 27 days. So early start plus duration give me the early finish. Early finish becomes early start for the next activity, unless rule 1 that I'm going to explain now. Rule 1 is when the next activity is a merge activity. In this case, I will be using the largest early finish. So if we look here, this is a merge activity. What's merging into J? I have E merging into J, H merging into J, and G merging into J. This is the early finish for E, this is the early finish for H, and the early finish for G. So what we do, the merge activity, if there's more than one early finish, you will use the largest early finish. So if this is 10, this is 20, and this is 30, the early finish here becomes 30, the largest early finish. 30 plus 4 give me a 34.
Sir, what happened if we start F instead of I of tray.
Nothing happens. Let me show you. Let me show you now. Nothing will change. Okay, so look here. When do I start activity A, guys?
0.
0. Plus duration,
12.
0 plus 12. What's the outcome?
12.
12. Okay, what about here? What do I put here? What do I put here?
The 0 plus 9.
0. Okay, correct. So I put here 0 plus 9. What's the total?
9.
9. Okay, now, what do I do with this 12? Where does it go?
IFC.
Activity.
Correct. It goes to I, it goes to I, it goes to F, it goes to C. So I, 12 plus 15, what's the total?
27.
Okay. Now 12 goes here also. 12 plus 10, what's the total?
22.
Okay. And here again, 12 plus 10, what's the total?
22.
Okay. Now what do I put here, guys?
9.
9. Okay, perfect. 9 plus 10?
19.
19. And what do I put here?
9.
9 plus 24, what's the total?
31.
33.
33.
33. Now, what do I put here? This is G. What do I put here?
22.
32.
No, it's not 32. It's 22. So 22 goes here. 22 plus 35, what's the total?
45.
57.
57. And here, what do I put?
19.
19 plus 40?
59.
59. Now I have this activity J. J is a merge activity. I have 33, 59, and 57. Which one is the largest?
59.
59 goes here, plus 4?
63.
63. Now 63, now this one here is again a merge
27.
activity. So there's 27, there's 22, and there's 63. Which one is the largest?
63.
63.
63 plus 6?
69.
69. That's what we call the forward pass calculation.
We are using the largest numbers.
What's that?
Where 63 comes?
Using the largest number, not the
63.
smallest.
Why the largest, not the smallest?
Yeah.
Because you are calculating how much will the project take you to complete, the largest duration. Okay, if you go and put the smallest, your end day won't be correct.
That may be shortest path algorithm.
Well, the shortest path to get the project completed is 69 days. Okay, if you go and put 22, that's incorrect because this will, finish in 63 days. So how could you start this activity in 22 days if this activity that is merging will not finish till 63? Okay, so if I'm going to go and say, for example, you're going to go and live in the house. How could you go and live in a house if, for example, the pathway hasn't been completed? Yes, they might have finished the garden, but you can't. You need to also things to finish inside. So they might finish the garden in 22 days, but they might not finish the house till 63 days. You can't tell me you can live in the house, after 28 days because you still haven't completed the actual house. You only did the garden, which is another activity. Does that make sense? Make sense, guys? All right, perfect.
Yes, sir.
All right, let's go and do the backward activity. So we're going to go, and all of these boxes, they're empty, 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 empty. We're going to go backward, and we're going to fill all of these boxes. So we're going to subtract activity times along each pass in the network diagram. Latest finish minus duration give me latest start. So that's here, my early finish. My early finish becomes the latest finish. So my early finish of 69 will move here, becomes latest finish of 69. 69 minus the duration will give me the latest start. Then the latest start that I get here, so latest finish minus duration will give me the, actually that's not the early start, will give me the latest start time. That's not, don't worry about that. Should be the latest start time. So 69 minus 6 will give me the latest start time of 63. Now, next thing, my latest start time will go to the latest finish time. So my latest start time here will become the latest start of the next one, latest finish of the next one. So here I have this latest start of 63. It will move here. It will become the latest finish. So if this one starts in 63, this one actually finish in 63. 63 minus 15, give me my latest start. 63 minus 10, give me my latest start. 63 minus 4, give me my latest start. So 63 minus 15 is 48. 63 minus 10, give me the 53. And 63 minus 4, give me the 59. Now guys, 59 is my latest start. What's my latest finish here?
59.
59, correct. And what's my latest finish here?
59.
Perfect. So 59 minus 35 is 24. 59 minus 40 is?
19.
19. 59 minus 24 is? 35. Now, let's look here. If this is 24, when does the one before it start? What's the latest finish of the one before it? If that's 24,
14.
let's look. If that's 24 latest start, what's the latest finish here?
14.
24.
It's 24. So this latest start becomes latest finish. So 24 minus 10 becomes 14.
14.
Now I have here latest start of 19. What's the latest finish here?
19.
19 minus 10?
9.
9. Now, there's another rule like the other one. When the next succeeding activity is a burst activity, you use the smallest latest finish. So this activity is a burst because there's two activities bursting from it. So I have, this is a burst activity. I have one latest start time and one latest start time. When I'm moving backward, I will use the smallest latest start time, latest start time. So if I have 9 and if I have 35, which one is the smallest?
9.
Okay, so 9. 9 minus 9?
0.
0. That's how I calculated my whole calculation. Now, the next thing you're going to do is you're going to calculate the critical path. The critical path you calculate it by doing latest start minus early start. So we know for a fact that the project will take 69 days to complete. 0 minus 0, guys, is what? Latest start minus early start. 0 minus 0, what's the answer?
0.
0. So latest start minus early start. That's 0 minus 0 is 0. 9 minus 9?
0.
19 minus 19?
0.
15 minus 59? 0. 63 minus 63, 0. Now here, 2 minus 0 is 2. 48 minus 12 is 36. 53 minus 12 is 41. 14 minus 12 is 2. 35 minus 9 is 26. 24 minus 22 is 2. So these here, this S equal 2, S equal 36, S equals 0. Anything where the slack equals 0 means the activity is on the critical path. Any activity on this critical path where the slack is 0, any activity there cannot actually be delayed. So if I delay B, the project will take longer. If I delay D, the project will take longer. Let me ask you a question. If I delay A, would it delay C?
No.
Okay, if I delay G by 2 days, will it delay J?
Yeah.
No, it won't, because it's 2 days slack. You have 2 days. Even if you started in day 24 and finish it in day 659, that's not an issue, because this activity can only start on day 59. If I delay this activity from day 27, is that going to affect my next activity start time if I delay it by 10 days?
No.
No, because I have a slack of 36 days. Does that make sense, guys? Thumbs up. Perfect. So any activity that is on the critical path, can I delay an activity on the critical path? Yes or no?
No.
Yes or no?
No. No.
Why no?
There is no slack time.
Yeah, if this increased to 60, this will have to start after 60, and this will have to finish after 70. You will delay your project duration. So this is really the foundation of doing the network diagram. This is going to be in your midterm exam. This is going to be in your final exam. And this is going to be into so many other calculations we'll be doing. Today, you'll have the chance to make so many of these calculations today in your class. So you will be able to apply everything I just taught you here. Don't be afraid. You will have much chance to go and ensure you do this and you understand it very, very well. Is Macon gone? Macon, are you still here? Okay. All right. So let's continue, guys. What we do when we go and create all of this planning, we can save on tools like Microsoft Project. We can save what we call a baseline. So if, for example, we plan activity A will take between 0 and 2 days, we save it as a baseline. Then what we do, we start comparing what's happening in reality. If I plan to finish it in 2 days, and if I actually finished it in 2 days, that's great. That's mean I am on time. If I plan to finish, let's say, this activity, if I plan to start it in day 8, but now it's going to actually start in day 9 because some other activity is now delayed, what's going to happen? Your whole project will be pushed out. And you can see that visually on tools like Microsoft Project. You need to know that not every activity is going to have a start-to-start relationship. If you go and look here, this will finish, then this will start. This will finish, then this will start. Not every activity is like that. Not all the links are finished to start activity. There are often lead time. There are often lag times. For example, sometimes you can only start the activity 5 days after the earlier activity. You can't do them immediately one after the other. There may be all of these relationships that you need to go and actually think about and bear in mind. So you have, for example, a start-to-start relationship. For example, an activity cannot start until the activity before it has already started. Finish to finish. An activity cannot be completed before the activity before it has already completed. Start to finish. Activity 2 cannot finish until the first activity has already started. So not simply finish to start. Not simply one activity has to finish before the next one starts. There are other relationships that you need to bear in mind, although we might not use them very much in practice in our lectures. Lag. An amount of time an activity can be delayed to begin or end. For example, I would say activity B can only start 10 days after activity A has finished. I'll show you examples of that. Look here. This is what we call finish to start relationship, but there's a lag. So Y cannot start, this is the start of it, until 19 days after activity X have actually finished. So the end of the box is the finish, the start of the box is the start. So what we say here, activity Y cannot start until 19 days after activity X has actually finished. Start to start relationship. Activity lay pipe cannot actually start, this is a start, until 3 days after trench have already started. So we need to do the trench first, dig it, then 3 days after we dig it, we start putting the pipes. Why? Because otherwise we're gonna have to wait a lot for digging, okay? This way you have 3 days, you've already digged, 3 days later, you start putting the pipes. After you put the pipes, you refill the mill. 3 days after, you already laid the pipes. So you put all the pipes, then you start closing the information 3 days later. That's really what this is trying to go and tell you. Here, testing. Testing cannot finish. This is a finish until 4 days after we finish the prototype. In other words, it's telling you cannot test very quickly. You have to spend the time testing. So testing cannot finish until 4 days after we finish doing the prototype. System documentation cannot finish until 3 days after we started the testing. So after you test it, you fix it, you do everything, 3 days later, then you can finish documentation because you would have incorporated everything you found out in a testing exercise. This is a combination. You cannot finish debugging until 4 days after you finish coding. But at the same time, you cannot start debugging until 2 days after you've already started coding. So you need to start the code after you've wrote a code for 2 days, then you start debugging. And here, 4 days after, debugging can't finish until 4 days after you've already finished all of this coding. This is some examples of all of these relationships, guys, that might exist to bear in mind in a network diagram. Now, we've been talking about various approaches. The traditional approach to project management is you do things sequentially. You do this, then you do this, then you do this. That's finish, start, finish, start, finish, start. But now we have something called concurrent engineering. What is concurrent engineering? Concurrent engineering is where we try to go and do things in parallel. We don't need to wait until until product planning has finished to start system engineering. A few days after we start product planning, we can start to do system engineering. Why? Because you could start finishing the project a bit early. You can release it earlier to the client than if you are doing everything in a parallel perspectives. My friends, there's a lot of information, things I've covered today. It's only the introduction. You will have so many exercises today that you will actually have to do today in a tutorial to be able to apply what I taught you. So it's not simply about me teaching you this. It's about how do you actually go and apply this today in your tutorial. That's why I say come to the lecture, because otherwise you cannot apply it in the tutorial. It makes it very, very difficult. So what you need to go and do is I want you to let me know, do you have any questions now before we move on to the next activity, specifically to the tutorial? Any questions at all? Anyone have any questions, my friends? Or no questions, give me the thumbs up. Okay. No worries, guys. Thank you very much. Now, guys, let's continue. Please review the lecture slides, tutorial materials, and notes if taken. Please read chapters 5 and 6. Continue preparing for your quiz and midterm exams, which are going to be happening next week. We have your quiz. It's very important you study the materials. You know how to do things. There will potentially be a calculation in that quiz. So if you don't know these activities, you probably won't be able to answer them. So please make sure you're prepared for all the questions that I might ask you. Thank you very, very kindly for your time, guys. I'll see you again a bit later in the tutorial. I appreciate all your hard work and want you to continue working hard, and let's achieve success.
Sir.
Yes, my friend.